Let me introduce our next speaker, Pragna Etikyala. She's a technical lead at Twilio. She has experience with asynchronous systems. She has efficiently streamlined Twilio's complex pipelines using workflow orchestrators and leading to notable improvements in manageability and operational efficiency. Before Twilio, Pragna held key roles at Amazon Web Services, Yahoo, and Kerner. So meet her talk, Building Asynchronous SOA for Modern Applications.
Hello everyone, I'm Pragna Etikyala and I'm currently working as a technical lead at Twilio, leading A2P compliance for messaging. Now I'm thrilled to be here to talk to you about how to build asynchronous systems and how workflow orchestrators can make it easy. Now let's start with defining what is service-oriented architecture or SOA. It is a very popular architectural pattern for creating software applications. Now it is designed with independent services that perform specific tasks, each being very self-contained. But synchronous SOA, on the other hand, takes it one step further. In this design, communication between services doesn't require an immediate response for the request, which means client can send a request and move on to other tasks without waiting for a reply. Now, this is particularly useful in systems where operations need to occur independently and in parallel, improving performance and scalability. Now, let's apply this concept to a real-world example. Think of a food delivery application. Once an order is placed, the customer doesn't need to wait for the restaurant to prepare the food before going ahead and doing other tasks. Like you can go ahead and browse for more items or order from different restaurants. Now at some point in future, you will receive a notification that the food is ready or delivery has happened at your doorstep. Now this ability to send a request and receive a response at an unspecified later time mirrors an asynchronous communication in an SOA. Now it enables the user to do multiple tasks independently without being held up for waiting for a response. Now, if you look at this diagram for synchronous SOA and asynchronous SOA, synchronous SOA sends a request and waits for the response to happen immediately. But asynchronous SOA, on the other hand, sends a request and you'll probably get back a 202 accepted response from the server, but the server will later send the response based on you can basically poll, or server can send like a event at a later time. Now let's talk about the challenges posed by building asynchronous systems. The first significant hurdle is the state management. In an event-driven architecture, like our food delivery example, maintaining and managing the state of each process can be a very complex task. Now look at what happens when you place an order. It triggers various stages. The order is placed, confirmed, prepared, and then delivered. Now each of these stages is an independent event, some happening concurrently with others. So ensuring the state of each event is managed accurately across these dispersed processes can be very challenging. Now, despite these challenges, it's vital to manage states accurately and provide a seamless experience to our customer. Now, imagine if your food delivery app shows the order is being prepared, while in reality it's already out for delivery. Now, that could certainly lead to confusion and potentially a dissatisfied customer. So the complexity of state management in asynchronous SOA is something that needs careful handling. Now, let's look at a potential architecture of the same food delivery service and how we manage state in this very event-driven system. So essentially, every time there is a event, it's gonna trigger a new operation. So essentially, instead of your system being a sequence of steps, it's basically your state machine all your state machine knows is it got an event X when the database is in event Y, so it's going to perform event Z. It doesn't really understand the order of sequence that happens in a food delivery system. Now, let's talk about resiliency. For instance, in our food delivery example, there might be scenarios where the payment gets declined or the restaurant fails to receive a notification about the order. Now, in a synchronous system, such an error might halt the entire process. But in an asynchronous system, it's critical that we design the system to be resilient. Now, it should have mechanisms to handle these errors gracefully and recover gracefully to keep the process running. Now, for instance, the system might retry the failed operations or notify the user about the issue or even backtrack if necessary. Now, resiliency in an asynchronous system allows for a more robust operations and definitely even in face of inevitable errors and exceptions. Now, the next one is traceability or auditability in other terms. Now, in a food delivery system, let's say take Uber Eats or DoorDash, there are many moving parts involved, such as there is customer app, restaurant systems, delivery partners app, and backend services. Now, when it comes to tracing a specific process or finding the root cause of an issue, it'll feel like searching for a needle in a haystack. Now, auditability is crucial for quickly identifying and resolving issues. Now, for example, let's say our customer reports that they did not receive their food even though the app shows it as delivered. Now, without proper traceability, it becomes very challenging to pinpoint where the process went wrong. Was there an issue with the restaurant preparing the food? Did the delivery partner encounter a problem during the transit? Now, proper traceability will allow us to follow the flow of process and identify the exact point in failure. Now, the next one is maintainability. Now, asynchronous systems by their very nature are complex. As they evolve and scale, the complexity only increases. Suppose we want to add a new feature like priority delivery for premium customers to our food delivery app, for example. In a very poorly designed system, this might require a significant overhaul, now which will impact multiple components and services. And similarly, onboarding new team members or debugging an issue can become a daunting task in a complex system. Now, the challenge of maintainability lies in ensuring that the systems can be easily modified, extended, scaled without causing disruption or requiring excessive effort. Now, addressing the challenge of maintainability is crucial for long-term viability and definitely for any flexibility of asynchronous like a system. Now, we've discussed lots of challenges. We spoke about challenges in terms of state management, resiliency, and then maintainability, auditability, and how all these things are a huge overhead for us. For example, if you take a asynchronous system which is pretty event driven, the state machine, as I mentioned before, the state machine wouldn't really know the sequence of steps. All it knows is I got an event X, database is in event Y, I'm going to perform event Z. So this is not very scalable because the system quickly gets very complex and it'll become harder to understand. And when it's harder to understand, it's harder to onboard new people to the team or make changes like significant changes or add new features. Adding new features will become harder. Now, after all the challenges, what is the solution for building asynchronous systems? Now, workflow orchestrators are very powerful tools that you can probably use when building asynchronous systems because these tools bring order and efficiency to asynchronous systems. Now, they act as these central coordinators, overseeing and guiding execution of tasks within a workflow. Now, similar to conductor in an orchestra, they ensure that the task is performed at an appropriate time and in correct sequence. By doing so, workflow orchestrators greatly enhance the overall efficiency, reliability, and scalability of the system. Now, let's explore how workflow orchestrators help overcome the challenges we discussed earlier. They help by streamlining state management. In our previous example of food delivery system, one of the challenges is managing the delivery process. One of the challenges in managing the delivery process is keeping track of different states. We have, in a food delivery system, we have different states like your order is confirmed, your order is being prepared, or your order is being delivered, or there is delay in your order. So there are different states. Now, workflow orchestrators take care of state management, and they monitor and manage each step, making sure everything happens in the right order. What do I mean by workflow orchestrators take care of state management? What I mean is, in our previous architecture, the challenges that we were discussing, essentially a state machine doesn't really know the sequence of things or order of things. If we configure a state machine to act a certain way in a state based on the event that we get, and if there is an edge case in production, which always happens, and you got your events not in the order that you expected. Now, in this case, if state machine receives an event in when the database is in state A instead of being in state Y, state machine wouldn't know how to handle that and simply will ignore that event, which is not what we want, unless you manually specify saying handle this event even if you get it in out of order sequence, which is a huge development overhead, right? When you are making changes in one particular state, having to know the entire code base, having to review the entire sequence of things to understand that we are not missing edge cases is a huge overhead for development. Now, workflow orchestrators basically utilize predefined workflows or sequence of tasks that represent the various stages of delivery process. Now, these workflows define the order in which the task should be executed and also specify any dependencies or conditions between them. By maintaining this organized flow of states, workflow orchestrators eliminate chaos and any potential inconsistencies in state transitions. Now, they also ensure that all parties involved, including customers, delivery team, and internal teams, have accurate and timely information about the status of the order. Now, this streamlined approach creates a very seamless experience for everyone, and this definitely makes our delivery process very efficient and reliable. Now, if you remember our previous diagram that we showed for our state machine and compare it with this. So in our previous diagram, we've seen how it was pretty, like the entire state machine is very event driven. You basically get events and you execute actions and you don't really know the sequence of steps. But in this new diagram with the workflow orchestrators, you can see how the sequence of steps can be predefined and how they, for example, initiate order will be the first step, confirm order will be the second step, preparation, initiate delivery, notify delivery. So all these are not really seen as disjoint events that our state machine is happening, but all these steps are seen as sequence of steps. So essentially, this is the sequence we are expecting it to move on in, and a workflow orchestrator will take care of executing these steps in this sequence and wait for any events when required. Now, workflow orchestrators also help in enhancing resiliency. Now, workflow orchestrators play a very crucial role in making the system resilient to errors. They have built-in mechanisms that handle errors and improve system reliability. Now, these orchestrators are smart problem solvers because they're equipped with strategies like automatic retries, time to close, and backups. Now, imagine a scenario where an error occurs during the delivery process, such as failed payment, which is not unheard of or uncommon. It is very common that a lot of times something goes wrong in productions. In this scenario, let's take an example of a failed payment transaction or a communication issue with a restaurant. In such cases, workflow orchestrator takes immediate action to recover from the error. It may automatically retry the failed operation or apply backup strategy to give system time to resolve the issue. Now, by handling errors in this way, workflow orchestrators ensure that the entire delivery process doesn't come to a full halt. Now, it enables the system to continue operating smoothly even when unexpected errors occur. Now, with the assistance of workflow orchestrators, our food delivery systems become resilient and gracefully overcoming challenges definitely, and ensuring that we provide a reliable service to our customers. So far we've discussed about how workflow orchestrators will help us with state management, and also how it takes care of resiliency. In case of resiliency and retries, workflow orchestrators, it's just a simple configuration. You say, hey, this step retry it for maximum 30 minutes or maximum 2 hours, or retry it for 200 times, let's say. Because if you ordered a pizza and your payment system is down for longer than 2 hours, it doesn't really make sense to continue with your delivery order, because because your customer would be very annoyed waiting for that pizza. So the next one is enabling traceability or auditability. Now, traceability is a very crucial aspect of managing complex asynchronous systems, and workflow orchestrators play a very significant role in simplifying this challenge. Orchestrators provide comprehensive logging and monitoring capabilities. Now, this makes each stage and transition within the system visible and traceable. Now, with these capabilities, developers and system administrators can easily track the flow of processes, identify bottlenecks, and troubleshoot any issues that may arise. Now, the next thing is facilitating maintainability. While it comes to maintaining complex asynchronous systems, workflow orchestrators actually offer a very invaluable assistance. Now, one of the challenges in maintaining such systems is making modifications or adding new features without disrupting the entire system. Now, workflow orchestrators address this challenge by providing a very clear and code-based workflows, or workflows act as blueprint for the system. Now, this makes it easy to understand and modify the system. Now, with the help of workflow orchestrators, developers can make changes or introduce new features more efficiently. This streamlined approach to maintainability allows for the system to evolve and adapt to new requirements without causing unnecessary disruptions or delays. Now, the next thing is I want to discuss about how these workflow orchestrators empower developers' productivity. Now, empowering development productivity and helping with maintenance sort of fall in the same bucket, but let's discuss how this happens. Workflow orchestrators have a very transformative effect on development process, empowering developers to focus on what truly matters, and which is basically developing functionality that actually delivers value. Now, by abstracting the complexity of asynchronous systems, orchestrators provide a high-level programming model. Now, this allows developers to concentrate on business logic and core functionality of the applications. And essentially, the developers will spend more time developing functionalities that actually deliver value rather than getting bogged down by infrastructure concerns. With the support of workflow orchestrators, developers can more efficiently do their work, and this accelerates the development process by reducing the time to market. Now, imagine we've discussed lots of features for workflow orchestrators, like how they handle state management out of the box, how they provide a platform for auditability or traceability, and how they take the overhead of resiliency from the development. Essentially, you can set retries or make your workflows more resilient, and these things come out of the box. And workflow orchestrators also give you out of the box metrics, saying, hey, this is the status of your workflow and this is where things failed, or this is how many retries happen. So these metrics come out of the box for you. At that point of time, you can easily get metrics of how many food delivery workflows are currently open and currently processing, like how many customers are we currently catering to. So metrics like these completely come out of the box. And which means you are putting less effort uh, less effort for a lot of the features that are coming out of the box. So which means this will directly affect your productivity and accelerates development for you. The next thing is there are workflow orchestrator options. Now that we understand the benefits of workflow orchestrators, now there are lots of workflow orchestrator options available in tech ecosystem. Now these orchestrators comes in various forms, each with its own unique features and advantages. Some are open source, some are open source with managed solutions, some are proprietary based. And a lot of these have and all these workflow orchestrators have different advantages. Now let's look at some of the popular ones. First one is Apache Airflow. Apache Airflow is widely used open source open source workflow orchestrator. It allows you to define workflows as code using Python, and this provides flexibility flexibility and ease of understanding. Now, Airflow has a very vibrant community and an extensive plugin support for seamless integrations with various services. Now, I would use Apache Airflow for data engineering tasks and scenarios where steps of workflows may change frequently, but you want to stick with the same sequence of steps that that the workflow was triggered with. Now you might now want to handle the overhead of managing an Airflow server. And for this, astronomer.io provides a fully managed Apache Airflow solution. Now they take care of hosting on which you can run your workflows. And to add to that, Apache Airflow has a very active open source community. You see a bug, you report a bug, you can help fix it. You will have the community sort of help you or brainstorm with solutions, or you'll have that fixed very soon, because definitely the open source community is something to talk about. And I would again use Apache Airflow for very data engineering tasks, more data pipeline tasks. And it also, since it also has been around for quite some time, I think it's been around for close to 10 years now. So there is a lot of like plugin support and a lot of flexibility for Apache Airflow. The next one is Argo. Argo is a Kubernetes native workflow orchestrator. Now this is specially designed for cloud native environments. It leverages the power of Kubernetes to manage the execution of workflows. Now each step in Argo workflow is treated as a container. Now this allows for easy adoption of containerization benefits. Now Argo is very well suited for organizations who are already using Kubernetes and they are seeking scalability. Now Argo comes with like scalability, fault tolerance, and flexibility in their workflows. Now the next one is my favorite that I use most often is Temporal. Temporal is an open source workflow orchestrator that focuses on reliability and simplicity. Now it allows developers to define workflows as code. Essentially, there are multiple SDKs for Temporal. If you want to define your workflow as code in Java or .NET, Go, or I think there is a new PHP SDK also that's coming up. There is a lot of support for different languages for Temporal. So essentially, you can write your workflows as code, and this is especially useful if you have complex use cases or complex business cases which have a lot of branching. Like for example, if I were to write a feature on my food delivery service system, saying if the delivery partner reports a car breakdown, cancel the order immediately, notify this to the customer, and refund the money to the customer. So if I want to do a lot of edge case handling, a lot of branching in my use case, and my use case is pretty complex, I would definitely use Temporal. Now Temporal offers long duration execution with at least one semantics. Now this Basically, the activities are at least once semantics. Now, it also has built-in handling of failures and interruptions. It excels in managing stateful and long-running workflows while ensuring reliability and also ease of development. Now, one other thing I would use temporal for is if you have particularly long-running workflows. And if you have long running workflows and you need dynamic workflow execution, for example, you have 10 steps in your workflow. Now it's long running in the sense your workflow takes a week to complete because you're waiting for external inputs to happen and all that. And now you want to add an extra step, 11th step to your workflow, and you want all your existing workflows that are already that are already triggered to pick up this brand new 11th step. This is basically dynamic workflow execution. If this is a requirement for you, then temporal is the way to go. Lately, I've seen a lot of adoption with temporal, especially because temporal also offers a managed cloud service. So you don't have to maintain the infrastructure, and it is pretty scalable, and it works for both complex use cases and very simple use cases. And also my favorite part is that it offers that the workflows can be defined as code, and it offers multiple SDKs for you to go ahead and develop in whichever language that you and your team's comfortable with. Now, the next one is AWS Step Functions. Now, AWS Step Functions is a fully managed workflow orchestrator, which is provided by Amazon Web Services. Now, it simplifies the orchestration of a complex multi-step applications using visual workflows. So essentially here, the workflows are not defined by as code, but are defined by using Amazon State Machine Language. I think I remember it being called ASL. And step functions seamlessly integrate with other AWS services, making it a suitable choice for organizations that are already using AWS ecosystem. Now, it offers scalability, fault tolerance, and ease of use, and which will empower developers to build robust and scalable applications. So we had to do extensive research between choosing AWS Step Functions versus temporal. And a couple of key takeaways for us was AWS Step Function was great if all your if you're completely integrated in AWS ecosystem. For example, if you're already using Lambdas, if you're already using DynamoDB and DynamoDB triggers, Kinesis, all these things, Step Function makes it very easy. But a temporal, on the other hand, is more flexible. You can call anything, and it's not very locked into AWS ecosystem or anything. So that was one of the reasons I went to use temporal rather than AWS Step Functions. Now, when selecting a workflow orchestrators, consider factors such as complexity of tasks, scalability requirements, fault tolerance, integration with existing infrastructure, and convenience of programming model. Now, each orchestrators, all the ones that we've discussed, Argo, Airflow, temporal, step functions, and there's Netflix conductor, there's a lot more. Now, each orchestrator offers unique features and benefits, and they all cater to specific use cases and preferences. Now, evaluate whether a fully managed service like AWS Step Functions or Google Cloud Composer aligns with your organization needs, or if flexibility of an open source solution like Apache Airflow, Argo, or Temporal better suits your requirements. Now, regardless of the choice of workflow orchestrator, leveraging these powerful tools helps simplify the complexities of asynchronous systems. Now, again, as we discussed before, each orchestrator offers unique features and advantages. Now, but in the end, they all enable developers to build resilient, scalable, and maintainable applications. Now, harnessing the power of workflow orchestrators will definitely empower organizations to deliver better services, optimize their development processes, and stay ahead in today's dynamic and landscape. I hope you would, when the next time you're building an asynchronous system, although it starts off pretty small and easy, it might end up based on your use case, it might end up evolving into a complex use case. So I hope you would consider using one of the workflow orchestrators we discussed, or any other ones to simplify your life. Essentially, my rule of thumb that I would go for is, if I have a queue, or if it's an event-driven architecture, I would consider using workflow orchestrators as a replacement, because in my personal experience, definitely a game changer in building these systems and simplifying everything. So, ending with that, thanks a lot, everyone. That is it. That is all I have for today. Thank you, and see you at the audience section.